Okay, let's give you guys some practice now. So here, integrate this. So as a clue, keep an eye out on something of this form here. So keep an eye out on something being the derivative of another thing. So keep an eye out on this, and keep an eye out for the fact that when you differentiate inverse tan, you will get 1 over x squared plus 1. So keep an eye out for this, and also you have to use completing the square to get to this this stage here. Well, anyway, do whatever you want. Work out the integral of this. So press pause and have a go. Okay, so to do this, break this up, because at the moment you can, if you look at this here, the derivative of this is 2x plus 2. This thing here is very similar to this. So let's adjust this in such a way that we will have the derivative at the top. So let's adjust it in such a way that we will have the derivative at the top. But yeah, we need to rewrite this in terms of one fraction plus another. But the thing is, we want this to be the derivative of this. So let's leave this as it is. But then let's make the adjustment a half up here. Okay, so we are trying to rewrite this as this. But the thing is, so hang on, let's try and rewrite this as this, a half bracket x bracket 2x plus 2, because this thing now is the exact derivative of this. So we are trying to morph this into this. So rewrite it as this. So currently at the moment we've got x, and then this times this we've got 1. But that's what we've got at the moment. But here, so this thing here is exactly the same as this. But the thing is, if you look at this here, we are missing 1. So put a 1 over here. So now we can rewrite this thing here as a half bracket 2x plus 2, close it off, plus a half. Because we are trying to rewrite this in this form here, because we want this to be the derivative of this. So always try and keep an eye out for this. Okay, well rewrite this as this fraction plus this fraction. Now this is a constant, so you can actually take it out. So it would then become this. It would then become this. Okay, so currently we are here. Well, that would then take us to here. Okay, so now this is this now is the derivative of this. So we can easily integrate this part. So that would then give us this. Now, if you integrate this part here, it will give you a half natural log of this whole thing here, which will be x squared plus 2x plus 2. But then now we need to take care of this, and the other thing that we should keep an eye out for is x squared plus 1, because when you differentiate inverse tan of x, it will give you this thing here. So somehow turn this into this. So when we come to integrate this, it will give us inverse tan. So looking at this here, now we need to complete the square. So we want to rewrite this in this form here. We want to rewrite it as well, completing the square is us writing it in this form here. Something x plus something squared, and then maybe plus something else over here. We want to rewrite this in this form. So completing the square on this would be, well, your eyes will zoom into these two, and it's always going to be half of this. So that would be x plus a half of this, which would be 1, and then squared, and then and then take away the rubbish, which would be 1. Because yeah, look up completing the square. You should be able to do this by heart now. So you take away the rubbish, and then you plus the 2 here, plus the 2 here. So rewriting this would be x would be this plus 1. Okay, merge these two together. So completing the square on this will then give us this. Will then give us this. Okay, so hang on, we were here. Well, if you integrate this, this will then give you this, and then from here, complete the square, and it will give you this. And the reason why we're completing the square is because we want it in the form of something. We want it in the form of x squared plus 1, because we know that if we differentiate inverse tan of x, it will give us this thing here. So if you integrate this, it should give us this thing here. So that will then take us to this, and then notice that that this thing here, if you integrate this here, it will give you inverse tan of x. Okay, so overall the answer will be this.